you, everyone. Good afternoon. I'm really excited to be here today in Quebec to talk to you about anonymity and how things break. My name is Sarah. I'm an independent anonymity and privacy engineer, which is a good way of saying I'm fun employed. Prior to that, I was a security engineer at Amazon working on preventing fraud in machine learning models. And even before that, in another life, I was a computer scientist at GCHQ, doing stuff I can't really tell you about. All the work I'm going to present here today is written up on my site masquerade.press. I publish reports every month about anonymity systems and how they break. And you can find all the research I'm going to present today on there. Cool, so let's talk about what I'm going to talk about today. I'm going to start off with a very quick introduction to hidden service OPSEC. This is a fairly misunderstood area around how hidden services protect the users that run them. I'm also going to lead you through top five hidden service vulnerabilities that I see in the wild every day based on the research that I've done at the beginning of this year. I'm then going to move on to the heart of the talk, which is kind of what is happening in the real world and what happens if we try to exploit all these vulnerabilities all at once together across the entire dark web. And we're going to go through a few case studies, talk about things that have gone horribly wrong. Well, I am going to talk about de-anonymization strategies, and there's a few hints about the kind of sites that are involved in this. I'm not going to present any direct identifying information. Finally, I'm going to finish up with some thoughts on future research and talk about how we can start to fix some of the issues that I'm going to talk about. Back. So a quick introduction to hidden service OPSEC. I'm not going to bore you with how Tor works or how hidden services do the things they do. Really, the only model that you need in your head to explain how this works is that hidden services hide the location, that is the IP address of the service, from everyone who tries to access it. And likewise, clients who try to access the hidden service don't have their IP addresses revealed. Nothing about the design of hidden services prevents you from revealing the location by publishing the IP address or publishing your full name. And that's really the heart of things that go wrong with this talk. Hidden services and software in general does stuff which unintentionally reveals the identity of the hidden service. So back in April, I started running a project called Onion Scan, and I scanned 8,362 Onion domains, of which about 3,000 were online over the few weeks that I searched enough to get some data. When you're doing this kind of research, you need to do multiple scans across every few weeks because hidden services are fairly volatile. And then I did a chunk of offline manual analysis to work out what issues I was seeing. All the issues I was scanning for were well published, well known, and well documented. So here's my top five. I'm going to go through them in detail. This has been slightly updated since I presented it back in April, based on some new research that I've done since then. So number 5 is open readable directories. This is a problem on the clear web too, but can be particularly bad on dark websites. What we see is administrators throwing backup.zip into one of their directories containing credentials or stuff like that. The screenshot on the slide is actually it's from a hidden service I discovered, which linked to 20, 24, 26 other hidden services, showing that the administrator there was probably hosting all of them. They were very varied, from a few dark markets to a social networking site to someone's blog. Whether this was someone who was paying someone to do hosting or whether someone was actually running all these different things together is an open question. The worst one right at the top there you can see is backup / that contained a few SQL dumps for one of the sites. Part of the problem with this is that a lot of the common software that we see running doesn't do its due diligence and lock down the folders that it creates. WordPress is particularly bad for this, considering how often we see WordPress blogs and marketplaces on the dark web. This also helps perpetuate some of the other stuff I'm going to talk about. EXIF metadata. So of the 3,000 sites I scanned, about 7.5% of them contain some amount of EXIF metadata, mostly date and time, camera models, firmware, software versions, how they were edited. It's not a big a deal as it used to be. If you look at Gwern's dark market dumps, you can scan those and dump GPS location data all day. People take pictures of their cocaine, timestamped to their address in Boston. But yeah, most sites these days actually, when you're uploading your images, they'll strip off all the metadata, re-encode it. So there's very little to go off of unless you're looking at the actual image itself.
But so,
yes, yeah, exactly. Clone sites. So about 29% of all the services that I looked at least one duplicate. And by duplicate here, I mean you took the SHA-1 hash of the page content and it was identical. So it's a very high standard of duplication. Since then, I and some other researchers have looked further into this, and it's probably closer to 40% once you account for dynamic page content like dates and updated listings, Bitcoin addresses, that kind of stuff. Some of these are deliberate copies, people just creating multiple versions of their sites for load balancing. But a lot of them are onion cloner type things where someone has set up a hidden service which is proxying to a legitimate, in quotes, hidden service, trying to spy on traffic going to that service and stealing what it can. There's very little way to defend against this, which is why it's number 3, because it's so prevalent. And really the only way is to give hints in your UX about what onion service you're visiting. And this can be hard for sites that are trying to load balance over multiple domains or perhaps don't have the technical expertise that some of them do. SSH fingerprinting. Also, I'm going to group under this software banner fingerprinting. About 25% of all onion services I scanned also had an SSH service associated with them. And this SSH service had a SSH key, which could be fingerprinted. And when we threw some of those into Showdown, IP addresses started popping out. This isn't that common, although it's certainly a de-anonymization vector that is more prevalent than it should be. Not just SSH keys. I've also managed to fingerprint sites and get IP addresses from FTP banner headers, SMTP headers, and also really unique service strings. So there's one site which had a very unique combination of PHP, Perl, whatever else installed, and that was being delivered in the server header. And we threw that in and out popped an IP address. And we were able to be pretty confident that that was the actual server that we were trying to find. And finally, my favorite, localhost bypasses. About 6% of all the Onion web services we scanned had an exposed server status page, which gives you a bunch of information about the site. Sometimes it's a direct IP address. A lot of the times it's co-hosted onions that you'll get to tell you that these onions are hosted on the same server. If the site is co-hosted along with a ClearNet site, you'll get ClearNet client IPs and a bunch of other stuff. 12% of all Apache services on the dark web have server status enabled and vulnerable. And it keeps going up. When I scanned back in April, I picked up 300. My last scan picked up 400 sites.
So for ClearNet sites, the Apache by default has that turned off. But for the setups that people are using for the core sites, the Apache that they're using for that has it all by default.
So yeah, it's not just Apache, and it's really a case of services treating traffic from localhost as special or authenticated. I've seen instances of open PHP MyAdmin instances. The one that you can see up there is actually a dump of a botnet that's keep going. It's still open. I keep trying to report it to the relevant authorities. They don't want to care, so that's fine. Personal wikis. I came across a home energy monitor the other day, which through Apache and because of some other things also was exposing information to localhost. And because all traffic from Tor looks like localhost for the hidden service, unless you set up your server correctly, it's a big problem. So yeah, back in April, I bundled all of these things together and I published them in a tool called Onionscan. And that caused a little bit of a stir. It got some press, but since then, the community's grown for it. We've grown from just doing HTTP and SSH to a wide variety of protocols, including Bitcoin, VNC. There's far too many open VNC hidden services. XMPP, I'm probably forgetting some. And when I look at traffic from hidden service forums, I can see that site admins are using Onionscan. They are scanning their sites with it. They are scanning other sites that they go visit with it. And it's really become a tool online for, you shouldn't be running a hidden service without at least running it once. And yeah, so since April, I've been publishing reports every month as part of the Onionscan project, working with people to both improve the tool and to sort of map the dark web. So we got a few goals, one of which is just to increase the number of scanned onion services. We don't do anything which we would consider unethical, like running Tor hidden service directories to kind of scrape sites. All of the information we gather is kind of open source from pastebin monitoring and Reddit monitoring and all that kind of stuff. Keep working on the number of protocols I just talked about. And we're looking at developing a standard for classifying onion services, which I'll come on to in a little bit at the end of the talk. Cool, mapping the dark web. This is the first map I produced of the dark web, and it's really pretty. And I'm just going to lead you through this. I'm not sure how well you can see the colors, but there's four types of connections represented on this graph. There's the green, which are sort of web links, sites linking to each other. You can see a few starbursts where you've got large directories linking to a bunch of other sites. You can also see a lot of sites that are only linking to each other, kind of in smaller clusters outside of this main graph, showing that they might be related or they might belong to the same ad network or something. That there's a very light pink loop in the center. This is from a FTP, so a web hosting provider, which exposes FTP on all of the domains that it hosts. So we can count how many websites it's hosting at any given time. Tiny small red clumps, which you can see across the graph, are Apache mod status instances, where we've been able to group sites because we see that they're co-hosted in each other's mod status pages, or they reveal the same mod status page, or they can be linked through some kind of host name that's not public, but they both reference it, so we know for a good standard that they're probably the same. And finally, there's the really large blue links that you can see. These are SSH services, and they're all connected to each other. There's about 1,500 of them altogether, and that's because they all belong to Freedom Hosting 2, kind of the predecessor. Freedom Hosting 2 came after Freedom Hosting, which got shut down by the feds at some point. It is currently hosting somewhere between 15 and 20% of all dark websites, which is a ridiculous number. It's also buggy as hell, so it goes down for a lot. The last report I actually published for Onionscan was documenting the uptime and downtime of Freedom Hosting 2. And we can count that because we can look at how many SSH services are exposed on any given scan. And every so often it goes from 1,800 to 300. And so we can count. Talked about hosting providers. The biggest thing here is that you can see that there's a lot of single points of failure on the dark web. Freedom Hosting 2 is the biggest. There's a lot of other hosting providers which have similar issues, which we can see in the correlations that we do. And it means that they're fairly easy to do traffic correlation on if you know that they're all hosted on the same bunch of servers sitting somewhere on the internet. If you have the capability to go off and do some traffic correlation, you can probably pick up or work out where these sites are hosted and take whatever action you want. Oh, it's dark. I don't know if you can actually see this map, but moving on to sort of HTTPS certificates on the dark web. There's a lot more of them than I first thought, about 400. All of these you can find on my site, much larger full-scale versions. The very bright star, kind of right at the top, is Let's Encrypt. These are all Let's Encrypt's ClearNet sites that are also hosting a dark website or have a dark website hosted on their server that we can access. There's a bunch of other stars all around where we've been able to link sites through so the IP addresses, email addresses, the certificate authority that they're using. All of these things kind of added up together gives us some confidence that the sites are linked in some way. And there's a small cluster to the bottom right of this picture, which are all the legitimate hidden services. Hidden services with a legitimate SSH certificate, one that actually validates. And these are sites like Facebook, Privacy International, Blockchain, and a few others that have gone through the effort to get a certificate from the only certificate authority that accepts it, which is DigiCert, I think. Cool, moving on to some more case studies. Google Analytics and Google Publisher IDs. So back in August, we added the ability to onion scan to scrape a bunch of connections from sites, so email addresses, PGP keys, Google Analytics, Google Publisher IDs, and a few others. And then we looked to see what we could find. And the biggest thing we found was that pretty much every gambling site that wasn't Bitcoin related, so you weren't gambling directly with Bitcoins, sort of casino level sites were all linked, sort of all 120 of them. They all had the same Google Analytics ID, and digging in, they were sharing some content, even though all the sites were branded differently. Some of the sites were ClearNet and dark web, some were just dark web. But this has pretty big implications for how we count the type of content that's on the dark web. There's a lot of publications, a lot of studies that go out and they count the number of hidden services, or they do some kind of statistical analysis on the hidden services. And they say, oh, gambling sites make up 2% of the dark web. Well, they don't. All the gambling sites are linked to the same operator. We know that. And so you can't really say they make up 2% of the dark web. It's one syndicate. If there is one syndicate running gambling operations on the dark web, probably open for competition, I would guess. It wasn't just the casinos example. I also found an example of a drug marketplace, which had a Google Analytics ID. When we looked through ClearNet sites, which had this, we found one social media consultancy company which shared this Google Analytics ID. Is there a relationship between there, or did they borrow a theme, or I don't know, I won't speculate. But this is certainly an avenue for producing ClearNet correlations. And we move on to Bitcoins. Bitcoins are really popular. In fact, I'm going to show you the next slide because it's more relevant. This was my first attempt at graphing the relationships of hidden services which shared the same Bitcoin address. And as you can see, it's just a big mound of orange because there are so many sites that contain the same same Bitcoin links that it was really impossible to visualize them in this sense. Okay. Oh, the green at the top there is just some web links. It's just happened to get cut when I was doing this analysis. Let's go back. Yeah, so we found, I think it's close to 2,000 unique Bitcoin addresses. A lot of these were not conforming to the kinds of things that you would want to be doing if you were trying to stay anonymous. So there are a lot of, I'll call them scam sites, kind of double your Bitcoin, triple your Bitcoin, 100x your Bitcoin. They all share the same Bitcoin address. They're all effectively being run by the same entity, or they're being cloned and man-in-the-middled, but I don't know to what end. And sadly, you can see if you just go to the blockchain, you look up the Bitcoin address that's there, they never refresh it. So you can find the history of everyone who has sent money to the service trying to double their Bitcoin or 100x their Bitcoin. And it's more people than you would hope it would be for the future of humanity. Also there, you can see at the bottom that we found instances of Bitcoin addresses across sites that were seemingly unrelated to each other. This was kind of the most visible one. We found 2 pastebin sites, one of which had a fairly obvious Bitcoin address. The other one was hidden in the comments. Whether someone had just decided that they wanted to run a pastebin site one day and copied an existing one, but the designs are fairly dissimilar, and there wasn't any other information in the source which would make me believe that they just copied the source code straight up and ran it, which means I suspect that they produced 2 sites and one day maybe turn that on. But it wasn't just this. A lot of dark marketplaces don't generate a new Bitcoin address for every transaction that they do. This means that if you click through and buy an Apple MacBook on one site selling fraudulent Macs, and then you click through another site selling cannabis, you might end up sending money to the same Bitcoin address. This can be very useful if you're trying to correlate who owns which marketplace. And that taps into what I was saying before about analytics IDs. There's a lot of information out there that we can use to derive the probable grouping of sites, sort of who owns what, or at least the same syndicate or the same group of people operate sort of these 10 sites. And depending on the makeup of those sites, we can then more accurately perform calculations to work out how many of these sites are actually unique and how much activity is actually happening on the dark web. Hey, so back in last week, I released Onionscan 0.2, which basically takes all of the rest of this correlation information and kind of gives you an at-home correlation lab. So you can run it up, give it a list of onions that you find anywhere across the web, and it will start generating correlations. And you can go through looking for Bitcoin addresses, emails, PGP keys, certificates. You can also create links yourself. The point that I'm trying to drive home with this is that there are definitely entities that are doing this already, that have been doing this for years. And I think a lot of people who are in the privacy space understand that on a conceptual level, but don't understand that on an intuitive level about how easy a lot of these identity correlations are. It doesn't take a large-scale crypto break or a large-scale Sybil attack on the Tor network to start de-anonymizing a bunch of sites. All it really takes is $5 DigitalOcean account and 2 days, and you can start de-anonymizing a large group of sites. So a little kind of dialogue into the future and some research that I'm doing now, and sort of the path forward for this kind of research. I've started to look at user-specific correlations. So the new version of Onionscan allows you to kind of make your own dark web bots very easily. It was really annoying me that every hidden service paper I read started with, we wrote our own bot for this, and didn't publish it and sold it to some industry. So with Onionscan now, with like 10 lines of configuration, you can start pulling down listings, forum postings, vendor information, however you want, and Onionscan will structure it into its own correlation engine, kind of what we saw. Can I go back? So on that other page, it will appear as just another kind of correlation link, allowing you to not only correlate into that site, but kind of across all Onion services that you scan. So what I'm currently doing, and it will be published in the NNScan report that I'm releasing next week, is looking at a bunch of marketplaces. I've used NNScan to pull down the listings. There's like 100,000 listings that I'm currently going through. And I'm looking at things like where are vendors sourcing from? Where do they say they're shipping from? Are vendors active on different sites? Do vendors use the same names across sites? And if they don't, can we work that out based on what they're selling, where they're selling it from, the price that they're selling it from? And so the map up above is just a list of its product listings broken down by the country that the vendor is claiming that they're sourcing from. So right at the top, you've got the US with the most listings on Valhalla, kind of closer to 4,000. The UK is up there too, and it's a bit smaller, but there's the Netherlands, Germany, and Finland, which also have a bunch of listings. But really, you can see it's all over the world. There's still a few hundred products in China and Australia, Russia. So this isn't really restricted to one country, although some countries are far more popular than others, especially countries like the US. There's a lot of insourcing because it's a pain in the ass to ship anything through US customs usually, and trying to do that illegally carries a lot of risk. So you find a lot of vendors sourcing directly from in the US and grabbing whatever products they're selling from other channels. And now kind of more of a deep dive on content classification. The Deep Light report, which kind of triggered all of this back in February or March or whenever it came out, it published a report that claimed 50% of the dark web, more than 50% of the dark web is crime. And to do this, they only studied HTTP endpoints. There was no attempt at cloned analysis or co-hosting analysis. And there were no details on their classification methodology. They said, oh, we manually classified some sites, and then we ran this ML algorithm, whatever, over the sites to produce a bunch of different sites. And they had things like file sharing making up 10% of the dark web, but made no attempt to explain whether that file sharing was legal or illegal, or did that include whistleblowing, or what kind of file sharing are we dealing with? Yeah. And so I'm currently in the middle, literally in the middle, of manually categorizing 6,000 Onion sites. It's a pain. It's taking a long time. And as well as doing things like directly looking at the site, looking at keywords, looking at what would a regular person classify the site as. I'm also doing stuff like co-hosting analysis, so where I've been able to determine that two sites are related. I'm using that to kind of guide my view, and I'm trying to do that in a way that doesn't actually reveal vulnerabilities in the sites. That's also pretty difficult. But stuff like duplication and so kind of a core example that I always give is there are like 400 Bitcoin scam sites, the kind of sites that I talked to you about earlier on. And pretty much all of those sites share the same Bitcoin address. So if you were counting just the sites, or you were using ML to count the sites, you would say, oh, there are 400 Bitcoin scam sites, or W Bitcoin sites, or whatever. But there are not. There is one site. There is one operation. So in terms of the amount of scamming going on, that's linked to one entity. Some other examples are kind of going back to that open directory structure I told you about before. That operator was hosting 23 sites. A lot of them were related. A lot of them shared the same code. They were marketplaces tailored towards specific products. So there are a few cannabis sites, a site selling steroids. There's a social networking site, which I still don't understand why it was on that server. But this is the thing. I'm very interested in trying to work out how much crime is actually going on in the dark web. And to do that, you can't just look at the sites and look at the content and look at the listings. And I say listings because the same vendor sells the same product across 10 sites. That isn't 10 sites selling the illicit product. That is one vendor sourcing illicit products onto 10 sites. And that's a distinct difference, which isn't currently captured in the research. But yeah, you can't just look at all of those. You have to look at the real world and look at how these networks are being used and how they're being abused. And to actually say how much crime is going on in the dark web, you have to understand how much crime is going on in the real world. And even by the numbers, I did the maths, and you can probably find the Twitter rant at some point, but I did the maths on the dark web, stuff that they pulled out. And if you look at kind of the scale of the black market globally, it's something stupid like $100 billion. And then you look at the estimates of the busts from Silk Road and what the feds say, and even if you take what the feds say at complete truth, not hyped, not prosecute debate, then the dark web really only, by those figures, makes up less than 0.01% of all crime trade, black market trade going on in the world. And all those figures are completely hyped. There is new research that's coming out that shows that most of the dark web, when you're counting, isn't that. And these are the sites that when you look at them, they are not being cloned, they're not being duplicated because they're personal blogs, wikis, political statements, queer sites, whistleblowing. Last I counted, there were 29 secure drop sites for whistleblowing on the dark web. Those all look the same, but they're all technically run by different organizations, different media operations, and although there are a few scams of those too, it's a very difficult puzzle to kind of draw apart. And so on making things better, I honestly think that if anonymity networks are going to survive, if they're going to provide value to people, then we have to move away from the browser and move away from the client-server model. There's a lot of guides on the internet about how to set up your hidden service. Alec Muffet produces a great one. I love it. It's perfect, but it's like 4 pages long, and it goes through setting up your own. Your own mini local network and creating 4 separate net domains and all of this kind of stuff to prevent things like localhost attacks from localhost bypass attacks and things like that. And the average dark web user, the person who wants to use the dark web for publishing political content, for talking on a forum, under the guise of safety, for whistleblowing, is not going to follow that guide. They're not going to go through it, and they're not going to do it correctly, because there are only a few thousand people in the world that have the technical capability to set that up and to understand the anonymity and privacy impact of what they're doing. And so what I see is tools like Onion Share and Ricochet, both of which are available now. You should go use them. They're awesome. Onion Share is a tool you can use to share files peer-to-peer over the dark web. It's really simple. It's being baked into a few different operating systems. You just right-click, share, you give someone an Onion domain, and they can go and download the file. You don't have to upload to a shady pastebin site or a shady image upload site, which is going to either be vulnerable. I've seen image hosting sites where they're vulnerable to localhost attacks, and you can, even though they give you like a unique generated URL, you can just go and view that in the Apache mod status logs. Don't ever go and actually view the files, though. You will lose all hope. Ricochet, it's a project I've worked on a little bit. It's by John Brooks. It's instant messaging over Tor, peer-to-peer. You just run it. You get a address, which is essentially a hidden service domain, and you give that to people, and they can use it to contact you. It's been security audited. It's safe. And the key thing with all these tools is you can get away from the, putting it politely, large security nightmare that is the Tor browser. That is browsers in general. It's not just Tor. They've done a lot of work on Tor to make it as secure as they can, especially at the highest security settings. But you are still trying to do privacy and security things that carry the risk of life and death or life imprisonment in some areas, some domains, over software, which we know is terrible. Every security conference, every year we see 0 days in every browser. It's going to go on, it's going to perpetuate. If your adversaries have the ability to get a hold of 0 days, and they can, either by themselves or through the dark web, that can be used to target you. So the only way I can really see anonymity tools flourishing is to move away from the browser. Things like Onion Share, Ricochet are a start at that. I'm hoping to see more in the coming years. One thing that I'm very excited about is OpenBazaar. It's a peer-to-peer marketplace. So you can set up your own marketplace, you run your own server, and then that gets distributed over the web or over their sort of DHT. They don't currently have Tor integration. It's not currently anonymous. Don't use it for buying drugs or whatever. But they are looking at Tor integration. And I think that once they do, we will see a trend of new marketplaces moving away from their client service model to a more peer-to-peer view, because it is the only way that they're going to get the business. Because vendors are going to wise up. Vendors don't want to get caught. Buyers don't want to get caught. And hopefully they will move to where everything is secure and private. And as we start seeing more of these applications having anonymity and privacy baked in by default, then we start seeing a more secure web. And yeah, so there's a lot of opportunities in things like blogging solutions, social networks. All of these currently suck, both in a clear web privacy aspect and in a dark web. Dark web social networking sites are just terrible. They collect a bunch of information. They're insecure. They're all running on PHP, old versions of PHP. And there's no hope of salvation there unless we move away from that model. So before I get onto the summary, I kind of just want to talk a little bit about why I do this. I've kind of hinted at it throughout the slide, but kind of coming up this week, Quebec has been rocked by news that local and provincial governments and police have been spying on journalists, trying to gather information about their sources. That's fucked up in any free society, yet alone a country like Canada, which I love Canada. That's why I live here. It's the least scary place on earth. And so by using these tools, by making these tools better, by understanding how they break, I hope to make these tools better. That's why I released Onion Scan, because I think that having an incentive, having something that you can point to and say, now, you know what, for $5 DigitalOcean account, I can de-anonymize your anonymity setup. Be better. And by encouraging that and by being better, I'm hoping that we can start to see adoption and improvements of these technologies, kind of a freer world where governments impossible, proven through math, intercept journalist communications, kind of tools that take power away from centralized authorities and distribute it among the people, where I think it's probably the safest. And while that has downsides, things like human trafficking, child exploitation. I don't do this to help pedophiles and gun runners. But those crimes are happening anyway. They were happening before the dark web. They will happen even if the dark web gets shut down. And the thing about all of the crimes that happen on the dark web, perhaps besides hacking and 0 days, they all have a physical, real world component. You can't commit those crimes without existing in the real world and without leaving a trail in the real world. And so the betterment of the dark web technologies, while they may help you, they're not going to solve that problem entirely. Targeted action will solve those problems. And most of the time, when you look at Operation Hyperion this week launched across the web, it wasn't vulnerabilities in dark web tech that led to a bust of 3,000 buyers and vendors. It was package inspections, because you ultimately have to ship stuff. And it was, busts from previous sites where they've turned vendors and gotten address lists and all of that kind of stuff. I find it a myth that, this is effectively a rant on how people think the dark web is for crime, when, for the most part, it is a great tool that we can use to make the world a better place. So, in summary, anonymity is hard. Our tools suck. Our software sucks. People don't know the risks. They don't know what they're getting into. And a large portion of the dark web really isn't that dark when you get into it. It really isn't that. It isn't really that much of a web either. I always compare the dark web to, it's like GeoCities, really. There's a bunch of sites that people set up, mostly hosted on other people's infrastructure. A lot of single page sites, a lot of personal blogs, entries, people having fun. And there's a lot of legitimate uses like whistleblowing, queer rights activity, forums for people to discuss things in private, anonymously. Anonymity is a very powerful tool. I posted a picture from my hotel room of a Venetian mask, which I thought was very apt because, Venice, they understood the power of anonymity, the idea that people sometimes need to be someone else in order for society to progress and for views to change. And so, I would like your help. If this stuff interests you, if you want to find out more, you can find my writing on masquerade.press, email me, or find me on Twitter. And it's been great. Thank you for listening.